dimensionality reduction. Can anyone tell me what is the advantage? What does it mean? See, okay, so see, we are working on the data every time. Okay, we are working on the data, and this data, you for some applications the data may be huge. You may have as many numbers you are not able to handle. So in that case, a dimensionally reductions arrive. Okay. So data forms the foundation of machine learning. Everyone knows this. Okay. Sometimes it happens that a huge number of features. We are having huge numbers of features. The same example I can give you. Okay, just a minute. I'm showing you the assign. See, if you are working on this, suppose house data. How many features are there? These are the number of features. Can you see
Yeah.
these columns? These are the number of features. There may be the case that all the features are not relevant to you. All the features are not relevant to you. Okay, so in that case, there may be the situation where you need to reduce the number of features. Okay, because sometimes handling too much features maybe cause you too much cost. Okay, so that's why dimensional reduction is here. Okay, so coming to the point, yeah. So sometimes data can contain huge number of features. If I talk about the same example, see, housing price data. So you are having 13 features here. You are having 13 features, and there may be the case all the features are not important. So in that case, we need to reduce the dimension. Clear? Now, what will be the case when you need to reduce the dimension? Redundant information. Just an example. Anyone can tell me what is the example of redundant data? Anyone can tell me? Okay, see. Suppose you know the carpet area of the house, okay, and you know the number of floor. Okay, so carport area is suppose 1,000 square feet, and there are two floor in your house. So first floor is 1,000 square feet, and the second floor is the 1,000 square feet. So it is a 2,000 square feet. Okay. Now you are having one more feature that is called the built up area. So just tell me, built up area is required or not?
No, sir.
Because you already have the carpet area and you know the number of floors in your house. So obviously, if the carpet area is 1,000 and there are two floor in your house, then 1,000 into 2 will be the built up area. So there may be the case you may have redundant information. That means some information is dependent on some other things. Okay? That means a particular column is dependent on some others column. Okay? So that is called redundant. That is not required in your data. So sometimes you need to eliminate the redundant information. Clear? So that's why dimensional reduction is here. Now the importance is clear. Why is it dimensional reduction?
Yes, sir.
Clear? Yeah. So the definition is simple. It is the task of reducing the number of features in the data set. There are different ways to dictate this definition, but the simplest one is the reducing the number of features in the data set. Okay. So in machine learning, like regression classification, we have too many variables. Okay, just give me the mathematical definition. Do you remember this? Y cap is equals to mx plus c. Do you remember?
Yes, sir.
Okay, let me extend this. This is for one feature. Just let me. I always try to give you the mathematical way of thinking. So suppose I'm extending this and I'm just writing a plus b1 x1 plus b2. Instead of m, I am just writing b. And for instead of one feature, I am writing more than one feature. B3x3 up to Bnxn. What does it means? It means a linear regression. Linear regression. How many features? N features. Am I right?
Yes, sir.
Okay. Okay, so that means if you are creating your own model, so you need to find these parameters A, B1, B2, B3. So you need to calculate these all the parameters A, B1, B2 up to Bn. All you need to calculate. Now if n is large, then it is difficult to calculate all these parameters. Expensive, am I right? Yes or no?
Yes, sir.
What we can do, we can reduce the dimension of this. Reduce dimension, and instead of this we will do this. A plus B1 x1 plus B2 x2 up to BP xp, or where P is less than n. Obviously, P is less than n. So instead of using all the features, instead of using all the n number of features, we are just using P features. The features may not exactly the same. May not exactly the same. There may be the case that means you have transformed n features into P features, and the form of that features have changed. So instead of writing x1, x2, you can write some other variables. Like you can write x bar, or you can write x cap, or you can write x dash. Okay, so instead of using n features, we are using P features, and where x dash, x1 dash, x2 dash up to xp dash are the new features, new P features. Clear? So the mathematical definition is clear. Why is dimensional reduction, and how we mathematically think about this. I just gave you a simple example of linear regression where we are supposed to build a linear model for n number of features. So we need to calculate these parameters A, B1, B2, B3 up to Bn. If n is very large, then it is computationally expensive. It is computationally expensive, and it may sometimes it will take a lot of time to build your model. Okay, so if suppose you are having millions of attributes or samples, and each sample is having maybe 100 features, so that is very computationally expensive. ठीक है, just an example फिर से देखिए. Suppose the same thing, the same data we were having. Now we were having, these are called what? These are called our samples. Maybe this is suppose 10 to the 5 samples you are having, and these are called attributes, features. Suppose you are having 100 features. So if the number of samples are large and the number of features are also large, then it is computationally very expensive. So what we will do, either we can use a less number of samples. Okay? Suppose you are having images of cancer patients, you are having 10 to the power 5 images. So the data set is very large. Okay? And suppose each image is having 100 attributes, then it is very computationally expensive. So sometimes we try to reduce the dimension. That means instead of using all the features, we will use some sets of that features. So that is called dimensional reduction. That is clear?
Yes, sir.
Okay, so I'm saving this handwritten so you can see the in the mathematical way. Okay, so there is a terminology used. Yeah. So the process of density reduction, that means transforming data from high dimensional to low dimensional. That's it. Clear? It is also important, that is blah blah blah, not yeah. So sometimes you will have this question, what is curse of dimensionality? Nothing new. What is curse of dimensionality? So the curse of dimensionality is simple things. The higher the number of features, the more difficult it is to model them. So it is called curse of dimensionality. Sometimes in the interview or sometimes in the exam, you may have this type of questions. Okay. So the simple things, the higher the number of features, the more difficult it is to model them. So this is called curse of dimensionality. Okay. What are the issues we have already discussed? See, what is overfitting? I think this is new for you. If
No,
you
sir.
remember in the first class, we discussed overfitting and underfitting.
Yes, sir.
See, what is overfitting? Suppose these are your samples. Okay. And suppose this is your model. So model is too accurate to fit the training data very well. You can see it fits the training data very well, uh, but it will not fit. Suppose this is the testing data. Okay, color I think change. Okay. So it fits the training data very well, but it doesn't fit the testing data as good. So you can say suppose this is the testing data. So it fits training data very well, but it doesn't fit the testing data well. So this problem may arrive if you have a high dimensional data. Clear? So this situation can be there. Another situation is there in case of clustering. So this there may be the difficult to find the nearest features or similar features. So in that case, you may have the problem, or the last one we already discussed. It is computationally very expensive. So you need a lot of space and that computational power for building your model. Okay. So this is clear. What is curse of dimensionality? What are the issues with the high dimension data?
Yes, sir.
Now next comes what techniques we can use for dimensionality reduction. What technique we can use? What technique we can use for dimensionality reduction? See, okay, first one is the feature selection. I will show you a research paper where I will show you how they selected some relevant features. Okay. So first one is the feature selection. Mm, feature selection. Anyone can tell me what does it means? Okay, just see this example. Okay, this lectures. I'm showing you the one exam, one research paper. Feature. Yes, feature selection is there. Feature. Yeah. You can see this. See, in this paper, the author is working on mammogram classification. Mammogram classification, that means just classify whether the mammograms are the benign or malignant. That means the X-ray images are for cancerous images or non-cancerous images. Okay? So suppose the size of the image is we do not know how much size. So suppose the size of image is 128 by 128. 128 by 128 is the size of the image. So that means 2 to the power 7 into 2 to the power 7. That means 2 to the power 14. Okay. And suppose you are having thousands image. You are having thousands image. So what does it means? Friends, what does it means? Hello.
सर उतना समझ में नहीं आया ठीक से.
चलो चलो okay, mammogram classification. mammogram classification. Okay, so mammograms are the X-ray images. Do you know this?
Yes, sir.
Okay, suppose you are having thousands mammograms, thousands, and each mammogram is 128 by 128 size. Each mammogram, each mammogram. Okay, so that means how much computational cost it required? 1000 mammograms, that means 10 to the power 3, and these are the size of each mammogram. So suppose you can see these are the features. So 2 to the power 14, these are called the number of samples, that means number of images. These you can see the features, the image, that means the pixel values, or you can say the pixels of pixel of mammogram. So that will require a lot of computational, am I right?
Yes, sir.
Okay, so that's that I'm talking about this paper. So these are the mammograms. Suppose there are thousands mammogram, and each mammogram size is 128 by 128. So the how many, what will be the matrix size? uh, 1000 into 2 to the power 14. If you are just using the simple, uh, you are not doing some any kind of dimensionality reduction. So that is computationally expensive. Now what the author did in this paper, he used feature extraction technique, or you can say the feature selection technique. So he used, we are not discussing what kind of features we can select. I'm just discussing there is a one technique that is called feature selection or extraction. Okay? So he used this histogram of oriented texture. This is research based. We don't not uh, uh, discuss too much about this. Just see feature extraction. You can see in the research paper itself we use this terminology. ठीक? So this is clear. What does it means? Feature selection. Perform feature selection to remove irrelevant features. To remove irrelevant features that do not much help in the classification. This one is clear.
Yes, sir.
Okay. Suppose we are talking about this example. There may be some irrelevant features. Okay, we can see, suppose this date ID, this is the irrelevant. ठीक है, bathrooms, ठीक है, number of floor, waterfront view, I think view can be irrelevant features, condition can be irrelevant features. Am I right?
Yes, sir.
है ना? So suppose यहाँ पे एक pin code, there is also a one more feature, that is pin code, and you are also having latitude and latitude. ठीक है, so if you are having latitude and longitude, then what is the need of pin code? So you can remove that things. ठीक है, so that is called feature selection. ठीक है, sometimes क्या होता है कि we need to transform our data into some other form, or we need to use some statistical technique to extract important features. ठीक है, so we will see here. So first one is clear, what is feature selection? Just remove the irrelevant features and just select the features that are relevant for our classification or for our model. Clear?
Yes, sir.
Okay. Now next is more mathematical. See, so suppose the same example. These are what columns are called the features, and these are called the samples. Clear? So for this example, 10 to the power 3 into 2 to the power 14 will be the matrix size x. ठीक है, this is our x. ठीक है, if you just compare with the example that we discussed in the lab, housing price data, do you remember we use x by x as the training data, y are the testing data?
Yes, sir.
है ना? The same things we are talking about, just writing our data in the form of matrix. ठीक है? Okay. So technique from linear algebra. You are not aware what techniques are, so we will not discuss in detail कि क्या technique है उनकी mathematics. We just discuss कि क्या क्या technique है. So techniques from linear algebra can be used for dimensional reduction. So that is totally mathematic. That is totally mathematic. Techniques from linear algebra. What they did in using this technique, we just transform this matrix into some other form of matrix, and which might have some other other data. That means you are having some data here, and using some linear algebra, we just transform from this to this. And this might have some important features with a reduced dimension, dimension, reduced dimension. Or if the dimension is same, then we can extract some important columns or some important rows. Okay, so we will see here. So this one is clear. What does it mean? Technique from linear algebra can be used for dimensional reduction, specifically matrix factorization. What does it mean? Anyone know what does matrix factorization means? Anyone know what does matrix factorization means?
No, sir.
Okay, see, I'm just telling you. Matrix factorization. Also, do not talk about the matrix. Suppose you are having a number 12. We can write this 2 into 6. Yes or no? We can write this 2 into 2 into 3. So similarly, in numerical linear algebra, we are trying to write a matrix in the form of the multiplication of 2 or 3 other matrix. Got my point?
Yes, sir.
Clear? So we will, so matrix factorization. That means a factorized matrix. So original matrix is factorized as a multiplication of 2 or more than 2 matrix. Clear? Yeah. So this one most common example is the singular value decomposition. The most common example is the singular value decomposition. Okay. So I'm just recalling once again. We discussed what is dimensional reduction, what is the importance, what is the curse of dimensionality. After that, we are discussing the technique. Okay. In the first technique, we discussed feature selection. That means just select the relevant features and remove the irrelevant features. Okay. One paper I have shown you where the author used some kind of feature extraction technique. So he extracted some important features from the data. Okay. Next, we are discussing about the matrix factorization. These are totally mathematic and related to numerical linear algebra. Matrix factorization means try to write our matrix, original matrix in the form of the multiplication of 2 or more than 2 matrix. Till now, this one is clear to all of you.
Yes, sir.
A- Anything you want to ask? Any question? Can I continue?
Yes, sir.
Okay. So this one is clear. Now see, I'm just giving you one example, singular value decomposition. What does it mean? Original matrix A. Original matrix A is decomposed into three matrix U, S, and V. Okay. So original matrix A, we can compare this with this. Suppose we are having this data here. Okay, and we are decomposing this data into these three matrix or these three different data you can see. Okay. So U, S, and V, where S are called the X is the diagonal matrix. S is the diagonal matrix, and U and V are the orthogonal matrix. I think all these are new terminology for you. Orthogonal matrix. Am I right?
Yes, sir.
Okay, forget about orthogonal. You just understood that original matrix A is transformed into three matrix in the SVD. USB, where S is called the S is the diagonal matrix. मतलब कि S will be something like this. This S matrix. You may have some entries here, some entries here, some entries here, entries here, some entries here, some entries here. ठीक है? And फिर एक कोई U matrix होगी and then V matrix होगी. ठीक है? So you are having this. Now in the SVD, what generally we try to do, these entries having some pattern. Okay, so instead of using all the entries, we can use some subset of this. These are in the decreasing order generally. So instead of using the whole matrix, we will use some subset of this. Suppose yeah, we are out of 100 entries. We are using suppose 50 entries. So we will use 50 rows. Similarly, we will use from here. Similarly, we will use from here. So using this way, we will reduce our data. We will reduce the dimension. Got my point?
Yes, sir.
You know? So what we are doing in the singular value decomposition, it is just an example of dimensional reduction. Original matrix A is decomposed into three other matrix. Okay? In which one matrix is the diagonal matrix, and this matrix is having diagonal elements non-zero. Okay, so if we want to reduce the dimension, what we can do, we can select a subset of these matrix. Okay? So I will show you an exam a research paper here. SVD. You can see this example here. They are using singular value decomposition for image compression. Singular value decomposition for image compression. Clear? Hello?
Yes, sir.
है ना? So singular value decomposition for image compression. Image compression means same thing. So we are just reducing the size of the image. ठीक है? It is just an example here. Clear. So this one is clear. One example is the singular value decomposition, and in lab we do not think too much about the mathematics. We will use the Python library, and we'll see the working of the singular value decomposition. Clear? Yes.
Yes, sir.
Okay. Now next you can see this is most widely used in machine learning or in data science. Principal component analysis. Principal component analysis, short form is the PCA. Short form is the PCA. I will show you the example Python code as well here. Okay. So what we will see, PCA is defined as the linear transformation. The linear transformation that transforms the data to a new system that the greatest variance. अब ये थोड़ा आपको समझ में नहीं आएगा. So you can just think we are transforming the data, and we are just extracting the features that have greatest value, you can see. That have the greatest value, or exact term you can say the greatest variance, you can say. So I will show you the example here. Just a minute. The Python code. Can you please mute yourself? Okay, so the Python example, you can see this. Okay. Okay, so just say here, okay, I'm using a data set, and the data set is the load digits data set. So we are having digits data set. Okay. What is the size of this data set? What does it means?
So rows and column.
Yes, these means the number of digits. We are having this number of digits, and this is the features. This one is the features. Am I right? Number
Yes.
of features. Okay. Okay. So I'm just plotting one image. Okay. I'm just plotting one image. So digits dot image. I'm just plotting one image here. So it is just a handwritten digit. So it is one. Okay. I'm just plotting one digits. Okay. Okay. In this data set, we are having 64 features. 64 features. Can you visualize these features?
No,
I
sir.
think very difficult to visualize. Now we are using principal component analysis. So from sklearn dot decomposition, import PCA, principal component analysis. Okay. After importing this, we are using PCA2. I will show you the documentation, just a minute. Okay, PCA. See. Okay, PCH मैंने already लिख लिया number of components too. Okay, we will use PCA and see. What does it means? Number of component. Okay, copy for the other things. SVD, total, iteration, random. See, so it is a linear dimensionality reduction that use singular value decomposition. So PCA, what PCA use? PCA use SVD. Okay? The input data is centered, and this all these things. Just a minute. Yeah. Yeah. So I'm just using two components. That means I'm using only two. I will take two most relevant components. Okay. So out of these 64, we will just have two components. Okay. So PCA is equals to PCA2. Okay. And then we will use our data set. That means this is dot data, and we will fit and transform this. Okay. After that, this transform data will have the same number of rows. Will have the same number of rows, but the column will be reduced from 64 to 2 columns. You can see here. You can see how many columns are there now. Is it visible? We are having only 2 columns. Yes or no?
Yes, sir.
And in the original data, what are the number of columns? 64. So rows are same, number of samples are same, but the number of features reduced from 64 to 2. Clear? Now we can visualize this data. PLT dot scatter projected. This is the first feature, and this is the second feature. This is the first feature, and this is the second feature. Clear? So I'm just writing here, and you can see. Now we can visualize this. You can see this is the first feature. So this is the second feature. Clear? Hello?
Yes, sir.
Okay. Okay. So are you familiar why I have written this? C is equals to digits dot target. Do you know?
No, sir.
Okay, digits dot target. C. Digits dot targets are from 0 to 8. Sorry, 0 to 9. Because the digits are 0, 1, 2, 3, 4, 5. Okay. Now, if you see the documentation plt dot scatter, sorry, sometimes in the program you will find these things. That's why I'm trying to show you. Okay, C is none here. Okay, C and C. C is a color. Array like or list of colors. Array like or list of colors, and it is optional. Okay, so I'm just passing array. What array? I'm just passing their class or target value. So based on that, it will take the color. If the value is 0, so for all zeros it will take the same color. For all 1 it will take the second same color. Then all 2 it will take the same color. Do you understand? Yes or no?
Yes, sir.
No. So suppose I will actually this is the lab part. Suppose I will remove this. Okay, suppose I'm just removing this and see then what will happen. All colors are same. So you can't differentiate which one is 0 digit, which one is 1 digit, which one is 2 digit. Yes or no?
Yes, sir.
So sorry. Hmm. So that's why we use this. So that means we have different colors. How many colors depend on this? So suppose there are 10 values 0 to 9. So you can see the 10 different colors are there. Yeah, we do not know which one is for 0, which one is for 1, but there are 10 different colors. So you can see this is the example for PCA. Okay, we will discuss in lab in detail. Okay, so I will show you the two coefficients. That means the two component I will show you in the lab itself. Okay. Okay. So the next one is the manifold learning. Next one is the manifold learning. So what does it mean? Technique from high density statics. So that means in this case we need to use statics. ठीक है suppose for an example instead of using all the features you can use the mean value of those features, you can use the standard deviation or some other kind of statistical driven values. Okay, so that is clear. What does manifold learning? Yes or no?
Yes.
That means some technique from the high dimensional statics. High dimensional statics. And the last one that you will find in the research paper, that is called autoencoder. So before this, I will show you a research paper. Okay, just a minute. Okay, D drive, Rohit data. Hmm. Okay, I need to search. Just a minute. Just a minute. It will take only a few minutes, few seconds. So I'm trying to show you a research paper which use autoencoder for dimensionality reduction to handle a large amount of data. Yeah. Okay. Okay. So this paper, I think, just a minute. Okay. Yeah, you can see this paper is using some kind of encoder. Okay. And this is you need to study the whole paper actually. But in this paper, they are driving multi-layer perceptron. Okay. And using different layers, so they are trying to reduce the dimension of the data because this data is too large to handle. Okay. I also have the code here itself. This is the code. You can see the MATLAB code. So see here, this is suppose their original matrix A. Okay. So they use some kind of they drive their encoder in this way. That means what does autoencoder means? Just think about the machine learning. Think about the machine learning. In the machine learning, we create a model that will take our features. Okay, and using that model we will predict the output for the unknown. Okay. Now the same technique can be used to for data compression or for dimensional reduction. Yes or no? See, suppose you are having this original matrix A. Suppose you are having this original matrix and you want to transform this matrix into some other matrix, some smaller matrix. Clear? So what we can do, we can drive a model and the model will predict these values. The model will predict these values. Can we do this? So this comes under the category of autoencoder model. That means a model is used that seek to compress the data flow to a bottleneck layer. That means mm, we will have different layers. So suppose from here we will do some kind of learning and we will have this data here. Okay, the size of this data is less. Then we will have one more layer and we will again reduce this data and we will have one more layer and then we will again reduce this data. Clear? This one?
Yes, sir.
You know, so this is called autoencoder methods. Autoencoder methods. But these you will find most of the time in the research paper. In the Python, generally you will find this principal component analysis, or you will find just the feature selection. Okay, so these two are the most. I just gave you a brief idea for research point of view. Those who want to go for higher study, okay, then you might have the question about the auto encoder. Clear? So that is for today. Anything you want to ask?
No, sir.
Anything? कुछ भी?
और सर ये जो मैथमेटिक्स के जो क्वेश्चंस है उसका कोई आप ट्यूट ऐसा कुछ क्वेश्चंस एक्स्ट्रा दे के एलएमएस पे अपलोड कर सकते हैं तो प्रैक्टिस के लिए सही रहेगा।
Okay, mathematics का just an idea दीजिए which mathematics you are
बेस
talking about?
बेस थ्योरम एंड लीनियर रिग्रेशंस क्वेश्चन।
Okay, ठीक है. So I will note down Bayes theorem and linear regression. I will prepare some questions for you. ठीक है, this weekend on Saturday Sunday I will prepare some questions and then I will upload on the Moodles for practice purpose.
ओके, थैंक यू सर।
ठीक है, thank you. Anything else you want to ask? देखो अगर आपको if you want to see the SVD code itself, आप you can see this is a matrix. Use SVD. This matrix using this SVD we find three matrix USV. ठीक है, ठीक है. S is the diagonal matrix, so we have just taken the diagonal entries. ठीक है, and after that we did some kind of reduction. So you can see we have taken only these number of columns instead of the all columns. We have taken these number of columns from Rn to end. And Rn is the rank of it. But it is too mathematical, इसलिए आपको समझ में नहीं आएगा. But think SVD में क्या होता है? We just transform a matrix into three matrix USV. S is the diagonal matrix, and from this diagonal matrix we can take a subset of this matrix for dimension reduction. So see here they are taking a subset of this. You can see. Yes or no?
यस सर।
You know, so all actually mathematics we can't go in detail, but इसके लिए एक subject है linear algebra. So I have studied that subject in my PhD, so that's why I know the mathematical background of this. Okay, so we will meet in the, just a minute, I will stop the recording. Yeah, so we will meet in the next class or lab. Anything you want to